So we know that in the low frequency region, this is the response of my amplifier. So this expression is also, we have seen it in unit 2 when we are studying about the frequency response, we have studied this. So A low by A mid equal to 1 by 1 minus J FL by F. This corresponds to which region? This region, this increasing portion of your graph. So the increasing portion of the graph can be represented by this equation. A low by A mid equal to 1 by 1 minus J FL by F. So cross multiply A low equal to A mid by 1 minus J into FL by F. So this is the low frequency gain of the amplifier without feedback. So if I want to find the gain of the amplifier with feedback, then I have to use this equation. AF low equal to A low by 1 plus beta A low. I have to use the second equation that involves A low and AF low. A low is the low frequency response of amplifier without feedback, and AF low is the low frequency response of amplifier with feedback. So see here they have used the formula AF equal to A low divided by 1 beta into A low. And for A low, I substituted this equation, A mid by 1 minus J FL by F. What is your FL here? FL is your lower cutoff frequency. FL is your lower cutoff frequency in the amplifier response characteristics. So I told you for finding out the effect of bandwidth, I need to find what is the effect on FL, what is the effect on FH. So FL is going to be the lower cutoff frequency. Okay, so I'm substituting A low as A mid by 1 minus J FL by F divided by 1 plus beta into A mid by 1 minus J FL by F. So take LCM, simplify everything. So take LCM and simplify, multiply all the terms. You will be getting A mid divided by 1 minus J FL by F plus A mid into beta. So this is what you will be getting if you take LCM and simplify. See, the denominator alone, you have to take LCM, and 1 minus J FL by F will cancel on both sides. So effectively, numerator you have A mid, denominator you have A mid into beta plus 1 minus J FL by F. So this is the simplified expression after taking the LCM and cancelling out the common term, the denominator. See, these things you have to write and see once after the class is over, so that these derivations will be very easy and understandable to you. Remember, third sem exam is going to be offline. So unless you practice and read things thoroughly, you cannot even pass these subjects. So you observe the class very sincerely, understand and ask any doubts if you have. So this expression is clear. I am just taking LCM and simplifying. So A mid by 1 minus J FL by F plus A mid into beta. So now what I am doing, I am just grouping the terms. I am just grouping the real terms separately in the denominator. I am just grouping the imaginary terms separately in the denominator. So A mid divided by 1 plus A mid into beta is the real term, minus J into FL by F is the imaginary term. Okay, I am just grouping the real terms and imaginary terms separately in the denominator. Numerator, I have only one term, so I don't have any problem with that term. So now what I am doing, from the denominator, take out this term as common, 1 plus A mid into beta. Or as they are saying, you can do this also. Divide the numerator and denominator by 1 plus A mid into beta. The numerator will become A mid by 1 plus A mid into beta. Denominator, divide each term separately. So 1 plus A mid into beta by 1 plus A mid into beta will become 1 minus J into this term FL by F into 1 plus A mid into beta. Okay, so I am dividing the numerator and denominator by 1 plus A mid into beta. Numerator is just simple. Denominator, you have to divide each term separately because you have two terms. And A mid by 1 plus A mid into beta, you know it is AF mid. See, written A mid by 1 plus A mid into beta is AF mid. So I am using that simplification here. So this big term, the numerator will become AF mid. And denominator will be same, 1 minus J into FL by 1 plus A mid beta into F. So I am assuming this term. I am assuming FL by 1 plus A mid into beta to be a new term called FLF.